Your air conditioner has no water pipe hooked up to it, no tank, no faucet either. And still, that machine makes water every single day. And tonight that water is rolling out across your floor. So tell me, where exactly did that water come from? Why did it end up inside instead of going outside? And at what point do you realize this isn't just a leak? Your machine is actually dying. First, I asked myself, can an AC really make water out of thin air? It can, and field data says, on a humid day, a home AC can pull anywhere from 15 to 70 liters of water. But here's the creepy part. All of that water rides on a pipe about as thick as your finger, one you've maybe never even seen. Then it hit me. Once a leak starts, should you shut the AC off right away? Yes, and not even 1 second late, because water plus a circuit board means a fried board and a 4-digit repair bill. And the scary truth is, the real story only starts after you turn the machine off, because another danger quietly wakes up inside. Picture it, 2 in the morning. Your sleep breaks on a tiny little sound. Drip, drop, drip. You flick on the flashlight and see a streak of water running down the wall, pooling right at the edge of the carpet. Your first instinct says, throw down a towel. Your second one says, deal with it in the morning. Stop. Right at this moment, your house is sending you a signal, and reading that signal is now your job. For this video, I dug through field technician reports, manufacturer manuals, and engineering lessons. What I found is simple. Your AC does 2 jobs at once. It cools the room and pulls the wetness out of the air. Most people think an AC just makes cold. That one myth has soaked more floors than anything else out there. The truth is, cold doesn't get made, heat gets moved from inside your room to the outside. And along that moving path, water is born every day, silently, completely out of your sight. So water dripping out of the outside pipe means your machine is working healthy, and water dripping inside is where the villain of this story walks in. Now follow one drop of water on its journey and watch this whole story through its eyes. Your room's warm, damp air gets pulled in through the return vent, slides past the filter, and slams into a coil that's sitting near freezing cold. Science calls this the dew point, meaning the moment damp air touches a cold surface, the water vapor hiding in that air instantly turns into liquid. Exactly like the sweat that builds up on an ice-cold glass. Think of that coil as a cold hand, one that wrings the wet towel called air so hard the water just keeps coming out. And where that wrung-out water goes gets decided by a drain, which I'm calling the gutter, like the channel that carries rainwater down off your roof. When the gutter's fine, the water goes outside. When the gutter breaks, the water comes onto your floor. It's that simple and that terrifying. Meanwhile, inside, a fluid called refrigerant is racing around. And engineering lessons say, at the compressor's outlet, its temperature blows past 80 degrees Celsius. In the outdoor unit, the condenser cools that hot gas with air and turns it into a liquid. And even then, it still carries close to 50 degrees of heat on it. Then, the moment it squeezes through the expansion valve's narrow throat, the pressure suddenly crashes, and when pressure drops, the temperature crashes right along with it. That crashing cold is what turns the coil ice cold, so it can swallow up the heat from your room. The indoor unit's fan isn't a propeller at all. It's a skinny spinning cylinder called an impeller, because a big blade can't fit inside that slim body. And guarding the coil's exit is the thermostatic valve, a doorman with a sensing bulb, watching to make sure only vapor, not liquid, gets into the compressor. A beautiful system, no doubt about it. But the more beautiful a system is, the more skillfully its cracks stay hidden. The first crack is that gutter itself. That dark, damp, warm pipe is a 5-star resort for algae and fungus, and month after month, they build up a jelly-like sludge. One day, that jelly sludge chokes the pipe so badly the water can't drain. So it flows back into the tray fills, the tray overflows, the floor floods. In technician records, this clogged line is the most common cause of leaks, period. Right here, I asked myself, is this leaked water actually dangerous? The water starts as condensed vapor from the air, but after passing through a dirty tray and pipe, it doesn't stay clean. And the U.S. Environmental Protection Agency says wet drywall has to be dried out within 24 to 48 hours, or the mold risk climbs. The scary part is, once spores get into the duct, that same air circles right back into your lungs. The good news is, a clogged gutter is the cheapest problem of all. Grab a wet dry vac, press it against the mouth of the pipe, and the sludge gets sucked right out. And pour in 1/3 of a cup of vinegar every 3 months, and the algae gets scared to come back. But installers never tell anyone about this little drain, and even the manual dismisses it in a single line. And if your filter happens to be dirty, the story takes a turn in a whole other, darker direction. Picture the filter choked with dust, so the air can't even reach the coil's surface anymore. I asked myself, can just one dirty filter really flood a house? It can, because blocked air drags the coil's temperature below 0 degrees, and then the water doesn't just condense anymore, it freezes into ice. Here's the scary part. As long as that ice stays frozen, no leak ever shows up. Everything hides right in front of your eyes. The third crack runs even deeper, because the same ice gets born when the refrigerant runs low. When the pressure drops, the leftover gas gets even colder, and that's the backwards trap a normal eye never catches. And when this freeze-melt cycle keeps spinning round and round, the strain lands on the compressor, and that bill will burn you just hearing it. The fourth crack is the tray itself. A galvanized pan sitting underwater year after year rusts through and pops holes. So even with an innocent pipe, the water falls straight down. In homes where the AC sits in the basement, a tiny condensate pump pushes the water up, and if that motor burns out or the float jams, the basement floor goes under. The fifth one is dead silent. The house has settled a little. The unit isn't level anymore, and water pools in the wrong corner of the tray and slips over the edge. Nobody bothers counting these tiny drips, yet just one of them can bring down an entire ceiling. Now hear the real twist. The moment the AC shuts off, the 2 to 3 inch thick ice sitting on the coil starts melting all at once. Just think about it. A silent sheet of ice turning completely into water within an hour, all of it at the same time. That skinny tray and finger-thick drain were never built with this flood in mind. The water spills over the edge, and you're standing there thinking a pipe burst. No, the pipe is innocent. The blame sits with that ice, and that ice was born from a $10 filter. Now, it feels like the story ends right here. Clean line, new filter, all good? Stop. Because sometimes the fault lives at a totally different address, torn insulation on the copper pipe, where the cold copper touches damp air and starts to sweat. The result is water dripping on a wall miles away from the AC, and you end up blaming the roof. I saved the most modern puzzle for last. I asked myself, can a perfectly running AC still leak? It can, because in wind-free style low airflow mode, the cold plastic face gets so cold that on a damp night, water gets born directly on that face itself. Turn the unit off, and the problem vanishes on its own like magic. But the way it stops by itself is the trap, because on the next suffocating damp night, the same drama starts all over again. Cooking, showers, a door opening again and again, it all pushes your home's humidity up, and the full load of handling that extra wetness lands on the AC alone. Now for the most expensive question, which one can you handle yourself? And which one is dangerous to even touch? Changing the filter is your job. Once every 30 to 90 days, and it costs just a few dollars. Vacuuming the drain line and doing the vinegar flush are yours too. No argument about that. But the delicate job of swapping the drain pan is better left in a technician's hands, because one wrong nudge kinks the refrigerant line and the cost doubles. A lot of newer systems carry a float switch, a tiny plastic raft that shuts the whole AC down the moment water rises. Think about it for a second. On the hottest day, did that machine cheat you or did it just save your floor? Both are true, and that two-sided truth makes that little float the most honest device in the whole system. Refrigerant service, forcing ice off the coil or water anywhere near the circuit board. Leave all of that to a technician, because in America, working on regulated refrigerant service or recovery takes an EPA Section 608 certification. Honestly, I'm not totally sure these rules play out exactly the same way in every single home, because humidity, the unit's age, and the installation together can change the whole math. And once your unit hits 10 to 15 years old, the repair bills pile up until they're brushing right against the price of a new machine. No, actually, that's not the right way to put it. It's not repairs anymore. The decision to replace it is what becomes the real decision. The people standing in the Home Depot line during Houston's humid August or Florida's hurricane season do this exact math every single year, and now it's your turn. Now look at the whole picture all at once. The coil is that cold hand, wringing the air's wet towel and pulling the water out nonstop, and it isn't going to stop. The gutter is that drain, the one thing that decides all by itself whether the wrung-out water lands outside or on your floor. A leak doesn't mean your machine is broken. A leak means the path got lost. Now you know where to look, what to listen for, what to handle with your own two hands, and what to hand over to a technician. That drip-drop sound from last night isn't a mystery anymore. It's your house's own language. And now you understand that language. Here at Science Dissect, we break machines apart to see how they work, so you never have to fumble around in the dark. So tell me, the last time your AC leaked, did you fix it yourself or did you have to call a technician, and was the real fault the machine's or a lack of maintenance? Drop your city's name in the comments, because humidity changes the whole story, so which camp are you in?